Hi everyone, welcome again to our series on Cisco Security Integration into ACI. In this video, I'm going to show you how to set up ASA Failover and multiple context features with ACI. We're going to go through some presentation slides going over these concepts and go into the demo where I'll show you how to set up ASAs, how to set up APIC, and also we'll conclude with the redundancy demo of how quickly we can converge ASAs from active to standby in case of failure. My name is Goran. I'm a technical marketing engineer with Security BU at Cisco. Cisco Security integrates really well into ACI Fabric. We have our ASA device package that supports physical and virtual ASA appliances. As part of SourceFire acquisition, we had also embedded Firepower services into physical appliances that you see here on the left. And our ASA device package allows us to take a slice or actually send all the traffic for inspection to that Firepower module. We also have our Firepower device package that's been through beta, and it supports insertion of dedicated Firepower appliances, the virtual and physical that you see here, as well as our integration with the Firepower Management Console, which gives us full visibility into the threats that are happening in the fabric. As I mentioned, in today's video we're going to go over ASA Failover insertion, which applies to all ASA appliances, and also multiple context features and how it integrates into ACI. This feature is only supported on the physical ASA appliances. With ASA Failover Active Standby option with APIC, we have a couple of options on attaching our failover mates to the fabric. Our data plane options are to use a port channel, either single port channel with multiple ports grouped into a leaf, or virtual port channel, which allows us better redundancy with two leaf switches that we actually dual attach our ASA to. We can also use individual interfaces as VLAN trunks, and those can go into any of the switches within the fabric. For our control plane, we can cross-connect ASAs, the control plane for failover, link and LAN, and also we can go straight into the fabric and configure dedicated EPGs to allow those two appliances to talk and sync their configuration. Two ASAs in failover must mirror their attachment into the fabric because the config is synced fully between the two units. ASA multiple context feature allows us to take a physical ASA appliance and slice it into many different customers using virtual firewalls. These customers are segmented from each other because they have independence of their access lists, their inspections, security policies. They have their context interfaces that are dedicated to their context. The VRF within each context is that routing table that they only have to dynamically peer with the rest of the infrastructure. The management plane allows them management only of their own policy as well as monitoring, and each virtual context can be placed in either transparent or routed firewall mode. All these contexts can actually share the data plane as one big port channel to the ACI fabric, or they can have dedicated interfaces to each virtual firewall. They also share that failover control plane we talked earlier in the slides, and Firepower module itself that's embedded within the appliance. We first have to convert into multiple context mode when we want to use user contexts. And also after that, we recommend that you assign a MAC prefix to all of the interfaces attached to contexts. Then inside the system context with ASA, we actually define all the contexts and mark one of them to be our administrator context. Through this context, we can gain access to all of the resources within the system, changing into system or any of the user contexts, and we mark it with this CLI you see here. Within each context, we actually allocate interfaces and tell it which configuration to use that can be linked either on the system or off the box. Once we have our contexts created, we have to pre-configure them so they can talk to APIC, and these are some basic items that you see here, configuring the IP on the management interface, its route, so it can connect to APIC, and also SSL and AAA methods. We're enabling the SSL server on ASA, and with the local database here, you can see a username and password for this user that APIC will leverage to connect to this context. We can define the ciphers that SSL can use to communicate to APIC, and finally we must create a crypto key on each of the contexts to allow that communication to happen. If any of these contexts is designated transparent firewall, you have to convert into that firewall mode first before applying this config you see here. So this is a slide that shows you how we insert an ASA and configure ASAs with the fabric on the left, and also on the right is how firepower is configured through its management console that's embedded inside these ASAs. We're showing you here the best practice of high availability, leveraging the VPCs on the ACI fabric and also failover active standby on the ASA side. The way that this works is we first import the ASA device package into APIC. We configure the two ASAs so they can talk to APIC itself. With their concrete device configurations of failover, they'll be able to contact the ASA and APIC, establish that connectivity, and APIC will push the failover config so they become two active standby mates. All of the contexts that are pre-configured on that setup, APIC can register into different service graphs, and at that point push the data plane configuration and policy configs into the context, as well as their redirection to an inline or promiscuous firepower module itself. You can see here that APIC can configure port channels on all of the fabric switches, and for these two ASAs, primary and secondary, we have VPC 4 and 5 different VPC IDs. This allows the switches to move that active MAC to a new port channel, a new port, in case of a convergence or failure that happens on the ASA side. So on the right side here, the firepower modules are configured independent of APIC itself. So we have our firepower management console registering these embedded sensors, and based on their sub-interfaces, which were configured dynamically by APIC, they will show up inside the sensors themselves. We'll leverage security zones to actually create their own independent advanced malware, NGIPS, and access control policy itself. So for our demo, what we're going to show you is an application EPG, speaking through a service graph and leveraging a routed mode context, pod 1, inside a failover setup of ASA 5525s. This app EPG is going to speak to database EPG and vice versa through the firewall itself. We are leveraging the ASA device package that supports all the features that you see here, and APIC orchestrates all of these features on ASA. So with that, we are going to look at our setup now. So what I can show you here, I have these two screens on the right logged into two ASAs. If I do show version for you here, you can see I'm running 9.5 code, and this is an ASA 5525 unit. As you can see here, here's the version of code, and also ASA 5525, and this particular unit allows me with a license to configure 20 security contexts. If I look at my APIC here, what we're going to do here is I have this tenant pod 1 in place. I'm going to delete that tenant right now. And here I can see a lot of messages coming to device package debug log on APIC itself. That's what I'm monitoring of what's happening and when. So if I look at my common tenant right now, I can see that I have ASA Failover. This is my admin context within the ACI fabric here. You can see my active IP, the interfaces, my standby IP, its interfaces, and here, if I move this column a little bit to the left here, I can show you that my gig 00 is my external interface, 01 is internal, and two failover links are gig 02 and 03. These paths indicate where in the fabric these interfaces are configured for my two primary active and secondary standby firewalls. So to demonstrate the failover, I do have to show you how the failover config is configured underneath the concrete device here. So if I go to parameters here, I can show you that we have two failover interfaces with their own active and standby IPs, and they map into these two interfaces. One is failover LAN, as you can see here, failover LAN, and also failover link that maps into this interface. I do have more information here about my standby IP I want to apply, and also polling information is applied. We have some very tight poll times to allow us a sub-second failover if our active unit fails. So this is our failover configuration that APIC applies to our devices to make them actually active standby. So what I'm going to do right now is, easiest way for me to demonstrate this is to put the wrong IP addresses for this device. I'm just going to make them 122 and 123 here. And once I submit this, APIC is going to try to reach out to these, and it's going to tell me error because it does not see those IPs. It cannot communicate to them. If I refresh here, this device will be stuck in a NIT state. So while that's happening, what I'm going to do is I'm going to show you my admin context and show you the IP address on the primary active is 22, and if I do that on the secondary standby, I can see that the address is .23. What we're going to do now is we're going to log out of these units of ASA, log out of their consoles. And what we're going to do is we're going to run a script that clears the configuration and configures only admin context in place that we will register with APIC and let it apply failover configuration here. So here's that script that I'm going to run, and the first thing that it's going to do for primary is clear its configuration and then apply the new config in place, including configuring the admin context, and then log into the secondary and do the same thing, clear the config. We're done with that application of the config. So if I just go back up here to show you what we had done for the primary here, here's all the config for the primary. We are in system context here. We configure our context admin after doing clear config all, and assign it a management interface and the URL for its configuration. Mac Auto is an important item here in multi-context mode to make all interfaces have unique MAC addresses. Then we proceed with our pre-config that we had in place, which is to configure management interface, right? Do a no shut in system and then go into admin, configure all the information for it, and then proceed to enable SSL connectivity credentials and create an SSL crypto key. I also have here a command that allows me to set what ciphers I want to use with APIC. And that's pretty much the extent of configuring my admin context on the primary. And I do pretty much the same thing on the secondary here, as you can see. and secondary address here is .23. So if we go back into our firewalls, so here's the primary here, I can look at show context and see admin context in place. If I change into that admin, I can see that it has that IP address, but it does not have any access list, for example. If I log into secondary here, I can look at the failover configuration. It's not in place. I will also look at that on the primary, and I don't see any failover configuration. So what we're going to do now is we're going to switch back to APIC debug log under device package there, and we are going to correct our IPs for this device. And we submit that. We can see that APIC is already working on those devices. So if I actually do show run failover again, I can see that it applied the failover config to the primary. It also just did some more work here, and it applied it also to the secondary. And immediately soon after, the two units detected each other, and primary active has pushed the configuration onto the secondary standby here. So here, if I refresh, I can see that I have a stable device, and just looking at these faults, looks like these faults were cleared already. So that was from previous. So we do have our admin context registered in Tenant Common, and we have our two devices in failover mode. What we're going to do next is we're going to configure the contexts, pre-configure user context, so we can actually create a tenant and verify our configuration there. So this particular script is going to run only on the primary active, so I have to free up the console for it. And I'm simply creating a context, assigning management interface, and going in to actually configure that pre-config that we showed you earlier. So while this is happening, we have actually all of the 20 contexts being created here. We can see that standby is actually showing us that all of this is being configured. If I do show context, I see that we're up to context 7 in place. So what we're going to do now is we're going to look at how we create a particular tenant. So in this script that I have here, it's a number of Python scripts, and what it does is just puts it in a for loop. So what we have here is we have a Python script that creates a tenant and application profile with 3 EPGs in place, and then we have our failover device registered, function profile for it configured, service graph, and then applied through a wizard to create the contract and apply that service graph in place. So if we go back to our picture here, we will create service graph and get all the configuration in place to get this communication to work. In the meantime, our script had finished and configured all the pods. So if I go back into my primary active, and if I do show context, I can see all the 20 pod 1 through 20 contexts have been created. And if I go into pod 1 here, I can see that it has address 81. 10.10.11.81 is the standby, and it does not have any access lists. So at this point, we will look at our debug and we'll bring up APIC again. We have our common tenant, and we're going to run this script that's going to create pod 1 tenant. So as that script runs, I can see here pod 1 just got created. If I change into it, APIC is already working on my context, pod 1 context, and it has just created that pod 1 in deployed devices, and I can see VLAN 700 and 804. If we go back to our pod 1 here, we do our show IP, we can see the two data plane interfaces, VLAN 700 and 804. Our IPs are in place just like we had in the picture. And if I look at the access list, I do see that the ACL is applied appropriately. So at this point, I am going to bring up some communication within this tenant. So looking back at our picture, I have my app and database host. I'm going to execute some pings, and also iPerf UDP packets are going to come through. They all happen within this screen right here. So this is an app Linux that's sending UDP packets, and it sends 8 packets per second. And this is also an app Linux that's pinging to the database, and we will do the same from the database host to app Linux. So now that we have all of this communication happening, if I do show con, I can see ICMP and UDP connections created through my active context here. What we will do now is test our redundancy in place for the firewall solution. I have my standby ready to take over if anything happens to this ASA active. To cause that disruption, I will simply crash this device, active device. So if I look at that, I'll just simulate a crash happening on the active device, and what we're going to do is we're going to look at these UDP packets and ping packets and see if we can figure out if any of them are not received. So at this point, I'm crashing. I can see that the other ASA picked up right away. I'm going to quit all of these pings and UDP so that I can zoom in and actually figure out how many were lost. So here I can see that I lost some UDP packets right here. 8 were sent, and seems like the 2 were not received in this interval here, so within that second. And then if I look at my pings, I can see that I lost ping number 72. So a single ping was lost in this case from the app to database. And looking at the bottom, trying to identify the same, I see that I lost ping number 67 from database to app. So I hope this demo was useful for you. We had showed you how to deploy failover in multiple contexts in your ACI fabric as layer 4 through 7 device firewall, leveraging the service graph and ASA device package.